Okay, so we have a really short addition to our notes today. We're going to learn about writing net ionic equations. And so this is just an extension of what we have already been doing, of identifying the reactants and then identifying a precipitate. But we're going to end up writing just what's called a net equation. So there's a couple of steps to getting to this place. But again, I think you'll find this section pretty easy. So we are going to we're going to use dissociation equations in the end, and we'll see what that means. We are going to use our skills to identify a precipitate. And this part's new. We're going to cancel out what are called spectator ions. So these are ions that are present in the solution. But do not take part in the chemical reaction that's happening. Okay, so let's take a look at an example sample question. So it's going to be kind of a little lengthy one, but I'm going to have you write the whole thing out because this is the type of question that you might see. So it'll say, write the molecular, the ionic, and net ionic equations and then they'll tell you some reaction. For the reaction, in this case, sodium sulfate and barium chloride solutions. Okay, so I know my two reactants. One's sodium sulfate and the other is barium chloride. So first thing is, of course, writing formulas and those skills of that we've been using all throughout since we first covered chapter 4. So I've got sodium ion and I have a sulfate ion. And using the ion chart, I know that sulfate's a -2 and sodium's a +1. So that means that I need a quantity 2. So I'll put a 2 subscript there with my sodium. And I also know that I'm reacting that with barium chloride. So I'm just going to write these down to begin with. Barium, by the way, is a +2 and chlorine's a -1. So I'll need 2 of those chlorides to balance it out. Okay, so I know my 2 reactants, and now I'm ready to think about my products that I'm going to be producing. So I'm going to put my arrow, and remember we talked about yesterday with the homework, or sorry, not yesterday, that was today, with the homework questions, that you can start to look at some of these as what they're called double replacement reactions, but really they're switching partners. So the sodium cation is now going to be with the chloride. And the barium is now going to be with the sulfate. And with the charges of a +1 and a -1 on the sodium and the chloride, they'll be in a 1-to-1 ratio. And the barium with a +2 and the sulfate with a -2, they will also be in a 1-to-1 ratio. Okay, all of these things are aqueous solutions for the reactants, but I don't know what the products are. So now's the time when I get to use my solubility list and I get to take a peek and decide about them. I know for sure that sodium chloride is an aqueous solution. It is very soluble. So barium sulfate is my solid. Okay, so now I am ready to write this. This is what's called the molecular equation. This is what you got a little bit of practice with in the homework. So now I'm ready to write the ionic equation. And the ionic equation is, oops, looks like I'm kind of coming down off my paper a little bit. Let me move up. The ionic equation is where I'm going to write everything out in expanded form, which we did early on in the Pear Deck slides and also in the notes. So I'm going to show you what that looks like. So I'm going to, because these are aqueous, they dissociate from each other, and I can write them as separate ions, which they are in solution. So I have 2. This subscript 2 means that I will have 2, and I'm putting things in my boxes. Oh, except I didn't finish balancing. I'm seeing that now, but that's okay. We'll get back to that. So that represents 2 sodium ions, right? These are quantity 2 sodium ions, and I have also the sulfate ions. And those are also in the solution. So notice all I did was write this in expanded form. I kind of pulled them apart. Also, I'm still working on reactants. I still need to work with my barium chloride. And so the barium, I've got a single +2 ion in solution. And the ratio with the chloride, it's a 2 chloride to every 1 barium, so I will have 2 chloride ions in my expanded. Okay, now here's where I'm starting. I'm going to start over to my products, and I'm going to put my arrow here. And I'm also noticing that I didn't balance this, so I missed a step, and I need to go back real quick. And I noticed that, I've got 2 sodiums and 2 chlorides here. So there needs to be a 2 there. Okay, so now I'm ready to move forward, and I'm ready to write out the expanded form of the products. I'm writing the expanded things of the products of only things that are still in solution. So I can see that the sodium chloride, and I have 2 sodium ions from that. I have 2 of the chloride ions. They also are in solution. I'm just going to keep that going. And then notice that the product's going to look a little different. I am not going to write these as separate ions. They're going to still be written together because they are a solid. They are not in solution. They are the precipitate. Okay, fantastic. So now I'm ready to do this last step. I'm ready to cancel out the spectator ions and write my net ionic equation. So anything that appears on the left and on the right can be canceled out. So I see that I have 2 sodium ions on the reactant side, and I have the same 2 sodium ions in solution. So this is a key part, that they're both in solution, and so I can cancel those out. I look at the sulfate. I can't cancel the sulfate out because the sulfate is appearing here in the solid. It is not showing up as in solution anymore. So I'm going to leave that one. Same thing for the barium, but the 2 chloride ions, they are on both sides of the arrow, and so I can cancel them out. Alright, so now my net ionic equation I'm going to write, and we're going to see it kind of in a little different order, and I just want to tell you that this is fine. There's nothing wrong with the way it is. Okay, so this is my final net ionic equation. Oops, I off paper a little bit. Move it up. So I've got my sulfate ions and my barium ions, and it makes barium sulfate. Now, something that's really important as you work on other ones like this, sometimes these the coefficients will need to come along with the ions if you are writing them. So for example, if there had been a coefficient in front of this sulfate or in front of this barium or in front of the barium sulfate, then those coefficients would have continued on and shown up here in the net ionic equation. Okie dokie. So just a little reminder, I'm just going to put a little note down here at the bottom. That note, this is really kind of the whole purpose of it. Note the spectator ions sodium and chloride in this case cancel and do not appear in the net ionic equation. Okay, so this lesson, we're pretty much wrapping it up. So there's kind of two concepts here to be aware of. One is the overall process that we did of identifying spectator ions and producing a net ionic equation. The other would be to recognize what type of equation you're looking at. So, and the terminology that goes with that. So a molecular equation, not showing the ions all in that expanded form. The ionic equation, where you are showing them all in expanded form for the ions that are in solution, not for the precipitate. And then finally, the net ionic equation. And the net ionic equation is that one that after you've canceled out the spectator ions, and it's the simplest of all of them. And it's just showing the ions that were part of the chemical reaction. Okay, go ahead, and this will wrap it up for this part of our notes. There are some questions for you to practice out of the book to get some practice working with these same terms and the same concept, and you're welcome to send me a note if you have any questions. All right, bye.